Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is another video in differential calculus, specifically on differentiation rules and related rates. This is the first video, or the first section you're probably running into, that is not containing any type of new derivative or differentiation method. So we don't learn a new derivative of a function here. We're done with that pretty much. And we don't learn a new differentiation technique. This is actually just using our derivatives and applications. So what is a related rates problem? Why are they such a big deal? Well, generally related rates problems come from the fact that you have two quantities. It might be the volume of a balloon and its radius or something like that. And they're changing together. Their rates. There are two quantities and their rates are changing simultaneously. So the volume increases as the radius increases. So two quantities whose rates or derivatives can be related to one another via an equation defines a related rates problem. And some examples, I just wrote some down here, of related rates problems are finding how quickly the area of a triangle changes with respect to how quickly an angle is changing. So if an angle opens up in a triangle, the right pen here. As this angle opens, the area of this triangle will increase, obviously, and so and decrease as that angle closes. So the question is, how quickly is the area changing with respect to how quickly the angle is changing? Another example, finding how quickly two objects heading in different directions are moving away from each other. These directions could be something like this way and that way. They don't have to be at 90-degree angles. So you want to know how quickly is that distance between them changing. And we'll do a problem like that, or a couple of them actually, in our example sets. Finding how quickly water levels are rising in a container at a specific moment. This is another one that we're actually going to be doing. And finding how quickly the minute and hour hands of a clock are moving away from each other at a specific time. And again, we have an example that does that. So each of these is prime for using related rates problems. And there's so many other problems in physics that and science in general that will use related rates. So you could almost think of a ton of examples where two variables change with respect to each other, how quickly they change and whatnot. The hardest part about related rates problems for students is just the fact that they are all word problems. It's non-stop word problems. And so people get very intimidated. However, I just want to present a tactic. This is not my tactic. This is actually somewhat attributable to Poya, who is was a mathematician, and he wrote a book called How to Solve It. And anyway, he lists out a good set of tactics, and I've kind of adopted and adapted them. And I think most mathematicians have over the years. So here are the tactics. If you're handed any type of real world problem, the first thing you do is read the problem. Everybody needs a win. You want at least 1 out of 7 check marks here. So you want to be able to say, yes, I've read it. So read the problem. And then your second step is to try to understand the problem. And this requires you to either reword it, draw pictures. If there's some language you don't understand, look up some definitions, whatever it may be. But your best bet is to try to really understand what is being asked. And then once you've done step 2, you then can make a list of the unknowns, the things that they didn't quite state, or they say, tell me how quickly this is changing, or tell me what this is going to be. Then you could say, well, I'm going to let n equal that, or y equal that, or whatever you want. You should also list out the given information as well. And I use variables for this, so I'll showcase what I mean by that as we move into the problems. But so you read the problem, understand the problem, reword it, draw pictures, whatever you can. label your unknowns and list out the given information. Then you write a master equation. This is like, it could be actually two equations, but often it's a single equation, but it can be two equations that involve the given and the unknown quantities. And then what you're going to do, because this is calculus and you want to compare their rates, you're going to differentiate that equation. You're going to do implicit differentiation likely. And then you're going to substitute in the given information, solve and check, and state the solution. Now, that may not all make sense to you right now, but as we move through, I'm going to list out pretty much these steps and state what we're doing at that moment and kind of check things off as we move forward. This is just meant to give you the confidence to really tackle a related rates problem on your own. And like I said, there's a ton of them and they all look like big, nasty word problems. So open up your calculus textbook and after you're done with this, and just try a few.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.